Welcome to the night class. Today we're going to be talking about trigonometric identities, some of the basic ones. You do have a formula sheet in front of you, so if you have a highlighter and want to highlight the ones we're talking about, please do so. It will help you to kind of focus on what you need to be looking at rather than that whole big sheet of formulas. I would, if you have like a laminator or something, you could laminate that and keep it forever because you could use it in college. I have many students that come back and say they do use it a lot. So the reciprocal identities are the ones we start off with. They are the first three on the top left corner. Okay, 1, 2, 3. That second one does say secant. If it was cut off, you need to put the S. It got cut off because I punched holes in it way back when. And so that's why you can't see S. Mallory, I'll see what I can do about it. Because this is just ridiculously small, and I'll work on that. I didn't think about that. From now, if you want to, you can just use the notes. Okay? All right. So, basically, you need to, well, you probably already know these. Okay? The reciprocal identities are stuff you should already know. What's the reciprocal of sine? Cosecant. What's the reciprocal of cosine? Secant. And the reciprocal of tangent is cotangent.
Teachers, at this time, are going to dismiss all band members, cheerleaders, and dance team members.
All right. So basically, that's all these are. Sine equals 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Now, what's not on your sheet, but you need to know, these can be switched. Okay? Cosecant is the same thing as 1 over sine. Secant is 1 over cosine, and cotangent is 1 over tangent. So know the forwards and backwards of it, okay? Because you're going to be basically reducing big, long trig identities to simple stuff, all right? The next ones, oops, I went a little too far. The quotient identities are, well, it won't let me drag it down. There it goes. The quotient identities are 4 and 5 on your sheet, okay? Tangent equals sine over cosine, and cotangent equals cosine over sine, okay? That's basically what they are. You just kind of need to know them, all right? The Pythagorean identities, if I were to pick out 3 to memorize for the ACT, that would be the 3, okay? You'll know when to use those because what do you notice about all of them there? Anybody notice anything special about all of the Pythagorean identities? What do they all have? Braylon, shh. A square, okay? So if you have them being squared, think Pythagorean identities. Doesn't necessarily mean you're going to use one, but that's where your mind should go first, okay? If you see squares, and also don't just see the one they give you. There's 2 others that go with each one of them. And what am I talking about? Well, if you have sine x squared or sine squared theta plus cosine squared theta equals 1. Well, what would sine squared theta equal? Crickets. Use this and tell me what sine squared theta would equal. Not 1/2. Good try. Use this. 1 minus cosine squared. Okay? What would cosine squared equal? 1 minus sine squared. Okay? So understand, yeah, you know this one, memorize this one, but you can also use these 2. Okay? You can remember tangent squared theta plus 1 equals secant squared theta, but you can also remember secant squared theta minus tangent squared theta equals what? 1. You see what I'm saying? Okay? Be able to move them around like that. It will help you. But again, the first tip I showed you is probably the most important. If you see square, think Pythagorean identities. Okay? There's 6, 7, 8 on your sheet. Everybody good? The last 2 that we're going to kind of mess with today are right in the middle of your formula sheet. They are also labeled 1, 2, and 3, or excuse me, 1 and 2. Why does it do this? Come on, where'd it go? Why is it not? There it goes. Okay, for some reason it's mean sometimes. All right, so right in the middle of your formula sheet, you'll see law of sines. You see it? These two are right below it. Okay? These two are right below the law of sines. It says 1 and 2. Everybody see those? Okay?
Yes, sir.
So understand, there's a lot of formulas on here. Some of them you're going to use a lot. Some of them you won't use much. Okay? You may or may not use that too much. But wanted to show it to you. Okay? Let's do some examples of what we're actually doing here. We are simplifying expressions, and that's all we're doing. Okay? And we're going to do these three plus as many as we can do before the bell catches us, okay? And I'll add those to it. So, first suggestion, there's many ways to do these, okay? And the first suggestion is try to make everything into sine and cosine if you can. Sometimes you can't, okay? Most of the times, though, you can. So, this one right here, I'm going to rewrite it. It's cosecant theta over cotangent theta. Okay? What is cosecant that we can make it something sine or cosine?
1 over sine.
1 over sine theta. That would be number 1 on your formula sheet. Okay? Very first one at the top left. What about cotangent theta?
Cosine theta over sine.
Very good. Cosine theta over sine theta. Could you change it to 1 over tangent theta if you wanted to? Yeah, but that's not going to help us because remember, the suggestion I told you is try to make everything sine and cosine. It's kind of like when you're doing algebra problems, you want to try to get one variable, okay? Well, we're narrowing it down to 2 variables here. We want sine or cosine. And I know sine and cosine aren't variables, but you see my point, okay? Now, from here, you just math. How do you divide 2 fractions?
Reciprocal.
You multiply by the reciprocal, okay? So what would be the reciprocal of cosine over sine? Sine theta over cosine theta. The bottoms will cancel totally. And on top, sine and the sine do what?
Cancel.
They cancel. And you're left with 1 over cosine of theta. Do not ever simplify and leave it as a fraction. What does 1 over cosine of theta equal off of your formula sheet? Secant theta. That is my final simplified answer.
Coach Knight, where'd you get the cosine of theta over sine of theta at?
Yeah. It's number
Here?
5.
Number
on
5.
ratio identities.
Okay.
Okay, on your quotient. Okay, everybody good? Basically, you need to have 1, 2, 3, 4, 5, 6, 7, and 8 all highlighted on the top left. Okay, and you can use all of those.
I was confused about the number 3.
All right, everybody good on the first one?
Because we're trying to make it all sine and cosine. Because if you have tangent, then it's not going to be cosine.
All right, 15. Let me draw a little line here so we don't get them mixed up. Cosine x times cosecant x times tangent x. Well, do I need to change cosine x? Nope, it's already what we need. Cosine x. What is cosecant x? What can we change it to? 1 over sine x. And then tangent x, what can we change it to? Sine x over cosine x. Once you change everything, you math. You do math, okay? Since we're multiplying, we have a sign on top and a sign on bottom. What happens? They cancel out. They make 1, okay? We also, I know this isn't on top, but cosine over here is just by itself. It's over what? It's over a 1, so it's on top. This cosine is what? On the bottom, so they cancel, and so I'm left with 1. Piece of cake. Okay? Some problems are really quick and easy like that one. Some are a little longer. All right? I used to. I don't guess I think we need a rag.
Yes, sir. Never mind. Good, I can get one. I can get one.
All right, 16. Cosine x, leave it alone. What can I change cotangent x to?
Cosine x over sine x.
Cosine x over sine x plus, I'm going to leave sine of x alone. All right. Math, can I cancel the sine of x's? No, because we are adding, okay? Can I cancel the cosines? No, because they're both where? On the top, okay? So we just need to multiply. What's cosine x times cosine x?
Cosine squared.
Cosine squared x is how you need to say that, so people don't think the x is being squared. Remember, x is not being squared. Cosine of x is being squared, okay? So it's like, this is another way you could write it. That's what's happening. Cosine x squared, not cosine x squared. Okay? So the square, so that people don't get confused, they put it on the cosine rather than on the x. Okay? The cosine of x is being squared. Yes. All right? Divided by sine of x plus sine of x. Okay? And here's where the math gets really tricky because it's fraction things, okay? And we don't like fractions a lot, and we don't use them a lot. We plug them into calculators all the time, so we forget the rules. How do we add fractions? They have to have a common denominator. And if we were going to add these fractions, what would that denominator be? Sine of x. The first fraction already got sine of x, so do we need to change it at all? No. All right? Before I do it, 1/6 plus 1/3.
Whatever you do to the bottom, you do to the top.
Correct. What would my common denominator be?
Sine.
6. So the first one's good. What do I have to do to the bottom to get 6? Multiply it by 2, which means I also have to multiply the top by 2. Okay? Everybody remember that good little fraction lesson? Okay? You do the same thing over here. What do we need on the bottom of this sine x? We need another sine x. But if we put one on the bottom, we have to put one on the top, which makes it sine x times sine x is sine squared x. Okay? And now, since they both have a common denominator, we can write them both over 1 sine x. And what is cosine squared plus sine squared? They see they got the squares, so where do you need to look? Pythagorean identities. What is cosine squared plus sine squared? It is 1. And again, never leave it as a fraction. What is sine of x equal to? 1 over sine of x equal to, excuse me. Cosecant x. Okay? Everybody good? Awesome.
Wait, what did you see? How to change whatever into sine of x?
Very first one.
Number 1.
Number 1.
It's just a lot.
On your form.
So we're not solving.
Okay? You're not, right. You're not going to get x equals 2 or anything. You're just simplifying the expressions. Okay? As best you can. Everybody good? Let's do some more. Let's do some on your homework. I'm going to escape out of this and write on the Promethean part because it's a little easier. All right. So on your homework, page 428, I'll steal those problems. And again, we'll do as many as we can. So 44 is secant of x divided by tangent of x. Okay? And we're going to use our our newly found trig identities to simplify these expressions. They are expressions, they're not equations. We'll get to equations in the next lesson.
Are you still recording?
Mhm.
Okay. Which page is this on?
This is page 428. We're on Wednesday. Okay? All right. What can we change secant of x to? That would be sine or cosine. 1 over cosine divided by, what can we change tangent x to? Sine over cosine, which I believe is number 4. Is that right?
Yes.
Is that the fourth? The fourth one? Okay. And now that you changed everything, you just do what? You just math. You just multiply by the reciprocal. So, cosine x over sine x. And I'll go ahead and just multiply the bottom too, just to show you that it does cancel. Cancel, 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 cancel. On the top, what cancels? The cosines. Okay? And understand, when I say cancel, does that mean they make 0? Not on this case, they make what when you cancel? 1. Cosine over cosine is 1. Okay? And you're left with 1 over sine, which equals cosecant x. Okay? Don't let the variables mess you up just because the variable might be different on your book or in your question than it is on your formula sheet, or that you learned, however you learned it. It doesn't matter. Theta, x, y, z, they're all variables. Okay? Everybody good on 44? 45, very similar. We get cotangent of theta over the cosine of theta. So again, cotangent, what can we change it to?
Cosine over sine.
Cosine theta over sine theta divided by, do we need to change cosine? Nope, it's already cosine. So again, show you a little rule using numbers, okay? 1/3 divided by 2. When you're dividing a fraction by a whole number, remember you can make that whole number a fraction by putting it over 1, and then you flip it and multiply. So it'd be like flipping 2 would be 1 multiplied by 1/2. That is equal to 1 over 6. Okay? The shortcut is to just do what with the bottom two numbers? Multiply. Okay? 1 over 6. Boom. If you had 1/3 divided by 5, it's 1/15. Okay? Very, very quick and easy. So just because these are ugly or something we haven't seen before doesn't mean you do them any different. We're just going to take these two bottoms and do what with them? Multiply. So this will be cosine theta over sine theta times cosine theta. And the cosine theta is what? They cancel out. That leaves me with 1 over sine theta, which equals cosecant theta, just like the last one. All right? A lot of times this chapter is the hardest because you're not getting a specific answer, okay? I'm literally grading your work here, okay? Can you get to this by going another route? Yes, okay? And the next lesson we'll even see that more, okay? Somebody might do it one way, somebody might do it another way, but you all get to the same place. You got it right, okay? That's why it makes learning this a little hard, and also makes teaching it hard because there's so many ways you can get to the same thing, okay? Everybody good on 45? 46. We have sine of theta plus pi divided by cosine of theta minus pi. Now, I don't really like this problem. You won't have one like this on your test. The reason I don't like it is because we didn't go over this identity, okay, in the lesson. They didn't give us this one. But it is an identity. So if you'll look over here, right below your chart, you have sine of pi minus theta and cosine of pi minus theta and sine of pi plus theta and cosine of pi plus theta. You see those? Okay. And it tells you. So there's no numbers. You just got to kind of know where they are. So this top one, what is sine of pi plus theta? Negative sine theta. Okay. And the bottom one, I know it's in a different order, but it's the same, okay, is also negative cosine theta. Does everybody see that on your chart? Okay. They're over here. Right there, those two. And once you simplify it to that, it's pretty easy. The two negatives make a what? Positive. And what is sine over cosine? Tangent theta, which is number 4. Okay?
Coach, I've started to box my answers like you.
I do too.
Like, I never used to do that.
very much does that on everything.
I'm going to have to get out of that. And it's just for one specific, like I'm teaching calculus next semester, and when they take the AP exam in calculus, and I just learned this from my little AP class that I took, they say if you box your answer, you're locking yourself into that answer. So they said if you don't box it, and let's say you box this answer, but they were looking for something else that you had, well, now they have to mark it off because they're saying you declared that was your answer.
Well, that's why I just box everything.
So you just box everything? So they literally said, hey, tell your kids don't box your answer.
Like,
But that, again, that's only on the AP Cal test,
If
okay?
I don't know what the answer is, I just like box everything.
You just box everything.
The whole class is going to be a
They're saying just don't box at all. Just write your work and go on to the next
My paper
problem.
looks like John Mayer's
So-
album Room of Sweat. Like, it's just all the boxes.
So you're not bubbling in on that test?
No. Well, they do have a multiple choice part,
Yes, sir.
Caden, but they also have like 7 questions that are like this. I say 7. I don't even think it's 7. I think it's like 4 or 5.
Yes, sir.
All right, 47. All right, 47. Fun time. Sine x plus cosine x squared plus sine x minus cosine x squared. Okay? Do we need to change anything? No. They're everything sine and cosine. However, you may have forgotten how to do something that looks like this. So I wrote over here something to kind of remind you. If you have x plus 2 squared, that means you're going to write x plus 2 twice, right? And distribute, okay? There is a shortcut. If you notice, I squared the first number, x squared, it goes in the front. And I squared the last number, 2 squared, goes in the back. Every time. In the middle, what did I get? These two numbers, how many times? Twice. That happens every single time. Okay? So the shortcut is to multiply those two in the middle and double it. Okay? So if I square the first one, sine squared x, and I square the second one, cosine squared x, and in the middle, I multiply those two together, okay? Sine x times cosine x times what? 2. Okay? I get 2 sine x cosine x. And that just saves me from having to rewrite it and distribute and all that good stuff, okay? Again, it's a shortcut. You don't have to do it. If you need to write it all out, please do so. I'd rather you get it right. All right? Plus. Now we're doing this one. Same process, right? So same difference except it's minus in the middle. So I still square the first one. It's still sine squared x. I square the second one. What is negative cosine times negative cosine? Positive cosine squared, same thing. And in the middle this time, rather than getting 2 sine cosine x, I'm going to get negative 2 sine x cosine x. Okay? And now I add. What's 2 positive 2 sine cosine minus 2 sine cosine? They go away. They make what? They do make 0 because we're adding and subtracting. Okay? What is sine squared plus cosine squared? Number 5 or 6 on your formula sheet. It's 1. All right. Sine squared plus cosine squared is 1. Plus sine squared plus cosine squared again is what? 1.
Teachers, before
1 plus 1 is
release to go to the
2.
stadium, students, whenever
Y'all have a
you
great day.
building,
See you next time. As always, stay above the line.